Okay, so yeah, I'm here for the second year in a row at the TTFF Machine Learning Summit here. Who was here last year? Raise hands here. A couple people. Okay, sounds good. So I'm the CTO at Parsley. Parsley helps companies understand audience attention online. So what that means is we help companies that run some of the web's largest websites understand what their audiences are interested in and what they're paying attention to. And we do this at a pretty large scale. You can check out our website. It's parse.ly. You can also check us out on Twitter. That's Parsley over there. And I'm A. Montalenti. I just tweeted out right ahead of this talk, so you can find a tweet if you like search for TomTom there as well. All right, so what do I mean by understanding audience attention online? So how many people here, just raise your hand if you think in the last 30 days you've read TechCrunch.com or WallStreetJournal.com or Bloomberg.com or Huffington Post or NBC News, right? So a lot of people's hands went up here. And so the thing is that news content on the web and just content generally has huge readership. And so what we do is we directly measure this readership and increasingly also viewers of videos and things like that. And we analyze not just how much attention is being paid to the content, but also what the content is actually about. And as everyone here probably knows, the way you find content online tends to be through one of these major digital platforms. So in the US, the major platforms are like Google and Facebook and Twitter and LinkedIn and Reddit and so on. And so we measure not only the data about what people are reading on websites so that we can help these companies run their businesses better, sort of like give them a New Relic style performance monitoring, but for how people pay attention to information online. But we also measure where that traffic comes from these major platforms. And so we have this kind of interesting global attention view of about 1 billion monthly visitors across all of these websites. And right now we integrate directly with about 2,500 websites that are run by about 350 global media companies. So it's a pretty interesting data set of sort of like news readership and information and attention. So what kind of stuff do we measure there? So we provide them direct first-party analytics about things like how many visitors their site is getting, where people are spending their time, which articles they're kind of deep reading versus skimming versus bouncing from, which articles are getting shared on social networks, which ones are going viral on those networks, which articles are, or which topics they're publishing about frequently or publishing about less frequently. So we kind of do analysis on all of that. And the way we think about this is we're sort of telling the story behind the news article story, right? So they publish an article about a TV show, and we can show them like this article got all of its traffic from Facebook, or it got all of its article from Google searches, and people stuck around for 20 seconds, or maybe they spent more time than that. This is kind of how the product works and looks to the end user. At this point, this product is pretty widely used in the industry. So we have about 30,000 active monthly users at media companies that like monitor analytics about their site and understand attention this way. We track about 2 million page views per minute at peak across all of those sites. And we have to deliver all of this real-time analytics, because it's actually literally up to the second analytics with a 99.99% reliability rate. That's our internal SLO for delivering this. So it's like a pretty, I'd say it's like a legitimately big data like engineering challenge, right? And so this has also become like very embedded in the media industry broadly. So for example, this was election night at the Wall Street Journal's newsroom in New York City and in 2016, and that's the Electoral College map on the bottom, and then a Parsley dashboard is on the screen at the top, showing like the readership of Wall Street Journal content as the election was wrapping up in 2016. All right, so let's talk about what's going on under the hood here. So under the hood, we've got a pretty large scale time series database that is operating with some of the open source technologies you see on the right. Oh, yeah? Oh, sure. Can you guys still hear me? Yes, okay, cool. So it operates with the technologies you see on the right here. And so it's a pretty large scale cloud SaaS analytics system. So we have about 3,600 real-time CPU cores that are lit up with this stream processing system, Apache Storm, that we've done some open source work around. All of our messages get passed through Kafka, and then we use Kafka and Cassandra as our sort of distributed streaming data warehouse. So while the data is moving through the system about all the like view events and heartbeat events from video watchers and article readers and things like that. And then we do live calculations that get warehoused in a large Elasticsearch cluster. We have over 100 Elasticsearch nodes, and I think there's about 20 terabytes of like Lucene indices, in Elasticsearch that are used in production as the time series database. And then we also do a nightly job using Apache Spark, which does historical analytics. So basically that nightly job does like end of day calculations that close out all the analytics every day so that our customers can do like month over month and quarter over quarter reporting and things like that. So that's kind of the system there. This is a screenshot from Datadog, which is our like cloud monitoring system of all of our subsystems in production. We use AWS in production there, so this is kind of like a snapshot of that. And then what do we release publicly? So we do a lot of work in open source, actually. So we release some of our libraries for working with Apache Storm and with Kafka. We're actually the maintainers of StreamParse, which is the most widely used Python binding for Apache Storm. So if you want to do real-time stream processing, but you don't want to write Java code, you want to write Python code, you can use StreamParse to do that. We actually have a kind of layer underneath that that's called PyStorm that implements the communication protocol with Storm. And so this is really good if you want to do like low latency processing on streaming data. And you want to be able to do that in a way where you don't have to think about parallelization at all. You can just sort of throw cloud nodes and CPU cores at it, and Storm will handle it. And then we also maintain PyKafka, and PyKafka is the highest performance open source and community maintained driver for Apache Kafka for Python. It actually achieves performance through a C binding with librdkafka, which is like a way to talk to Kafka at the C level. And we also have a higher level Python API on top of that. We release some other open source stuff there that I show on the right, just in case you're curious. All right, so the big move of the company last year, and I think I actually like spoke about this last year when we were just getting started doing this, and now like it's been a full year of happening, which is great. But the big move in the company is moving from first-party analytics about single sites to actually having a team that looks at the whole data set as a big network data set, almost as like a panel of like what people are paying attention to on the web more broadly. And so one of the things we published a few months ago is a top 10 movies by attention dashboard that we update every week ahead of the box office releases. And for example, here you could see that the Black Panther was actually the top movie by web attention 2 weeks prior to its box office release. Then it crushed it at the box office and actually continued to crush it like for the next several weeks ongoing. And you can see that it remained the top web attention topic even against films like Avengers Infinity War and Wrinkle in Time, right, which were the next two films there. So we now publish these rankings on a weekly basis, and we're doing this kind of work now for all sorts of verticals, right? So it's like which companies are getting attention, which celebrities are getting attention, which films and TV shows and things like that. And so the way we do this is pretty straightforward. We're doing natural language processing against all of our content to identify these interesting entities, linking them up with a knowledge graph, and then surfacing up the analytics data under there. So to give you a sense of the scale of that network data, it's about 1 billion unique web mobile visitors per month. It's billions of page views per month. It's on the order of like 12 to 20 billion page views a month, billions of hours of attention, billions of clicks from Search Social and other places, millions of published posts, and millions of topics, categories, and keywords. So that's like a lot of data to warehouse. From a bytes and bits standpoint, it ends up being about a petabyte of data in our warehouse and about something on the order of like 30 to 40 terabytes per month of new data that shows up from all these sites. So we have to do different work in order to warehouse all that data and actually do kind of network analytics over it. So for that, we actually use Google BigQuery, which is sort of cloud-managed petabyte scale data warehouse. We still use Elasticsearch for indexing all the crawled content. And then we use some of this PyData stack that you can see on the right here for doing the analysis from there. The two big areas we're investing in are natural language processing on the text data. So we're categorizing all of our content, pulling out relevant topics, and clustering news stories together based on related storylines. So to work through a concrete example of this, it would be identifying all the politics content in the English language, then identifying all the politics content that talks about Donald Trump, and then clustering together all the content about the Michael Cohen FBI raid, and doing that all without having any prior knowledge of like Michael Cohen being an interesting news topic, right? That only happens when it happens, right? So we're doing all of that on this data, and we have some examples here of like what we're doing there, but it's mainly domain-specific keyword entity extraction. We're using word vectors to do the clustering of news articles, which is getting some pretty good results already. And we use classic document classifiers for the categorization. All right, so now I'm going to talk a little bit about just our data. I've got maybe 5 minutes left, so I'm going to focus on some of the insights we got out of the data, just a couple of them to highlight what we've been doing here. So this is our Donald Trump election dashboard from 2016. And basically like what this showed was that over the course of the 2016 election, all the articles written about Trump and the amount of attention those articles got is visualized here by the red line. And then the articles about Hillary Clinton and the attention those got is visualized by the blue line. And the volume of posts is on the bottom here, kind of Google Finance style, right? And so the interesting insight we got out of this data set was that Trump actually got about the same engagement as Clinton during the election, but got about twice as many articles written about him versus Clinton. And we ended up like doing a root cause analysis on this and discovered that it was because, or you could argue that it was because it was a more reliable source of traffic to write about Trump. Basically what you see here in these violin plots is that Trump, you could have a very high confidence that when you wrote about him, you would actually generate a median page view article here. But when you wrote about Hillary Clinton, you had a wider range. You could end up with like a really good article that produced a lot of traffic, or you could end up with a dud. And that effect was more pronounced for Trump than it was for Clinton. So from a attentional economy standpoint, you could say like Trump was a more reliable source of easy traffic. However, the media industry also just wrote way more about Trump, and that's what led to more attention. There's probably like other kind of sociological reasons for that. So we dig into topics aside from Donald Trump. Trump's kind of an easy target, right? But we dig into topics in general. And one thing that we did is we classified, using an unsupervised LDA model, actually, we classified all of our content across the Parsley network into a number of categories that we then labeled, kind of using human inspection to give them the labels afterwards, which are basically things like business and finance, sports, tech, then going up there, US presidential politics, entertainment, education, et cetera. And the dark blue bar is the amount of Facebook traffic that these topics get, and the light blue bar is the amount of Google traffic that they get. And so the interesting thing here, the gray is every other traffic source, right? So the interesting thing here is that Google actually does really well for like business, sports, and tech at high level. Kind of makes sense. People search for stock tickers, they search for sports teams. It does less well for lifestyle and US presidential politics. And that also makes a little bit of sense because people tend to stumble more into those articles, right? So that's why Facebook was more a discovery mechanism for those kinds of articles. So we started to like really get a lot of good results out of doing this kind of topic analysis. And so now we're doing it on a regular basis. Actually, we have like a live system that that a topic extracts articles literally as they're published and then does analytics over them. And so we're building some really cool stuff on top of that, which if you're interested in, come see me afterwards. Okay. So the last like little takeaway here, because I only have 1 minute left, kind of doing a abbreviated talk, is if you want to learn a little bit more about what we're doing with all that network warehouse data, you can come chat with me. We've actually got like a new product that's pretty cool that I can show you a super secret demo of, which basically does a good job of kind of showcasing these informational trends online. I also am the co-host of a podcast as of last year called The Center of Attention. And if you're just like really interested in like how the different audiences on the web are actually using the web and using mobile devices, we do entire podcast episodes like debriefing this data. So you can just search for the Center of Attention podcast. And otherwise, I'm really easy to get in touch with. So if you want, just reach out using any of these URLs or Twitter handles. And I'm glad to answer any of your questions.
We can take a couple of questions as well. All right. I see a hand down here.
I can just say it and then you can repeat it. You said you're all in AWS and then you said you're using BigQuery for day parting. Do Kafka events go to both?
Yeah, so the question is, I said we're all in AWS, but I also mentioned using Google BigQuery, right? And yeah, so basically Kafka, the way that works is that our production systems for our first-party analytics product live entirely in AWS. And then what we do is we take the stream, the real-time stream of events, which is over Kafka, and we also streaming write those into BigQuery, and that's where we do the warehousing kind of offline. It's a good thing that works that way, because if we were to do these kinds of network analyses against our production cluster, it would be like lighting up all the cores of Elasticsearch, because we'd have to query all of our data all the time. So we instead move it over into BigQuery, and we like light up Google's cores in BigQuery, but that doesn't affect production for us. So that's kind of the separation there. Yep. Any other questions? Yeah, go ahead.
Kind of just following on that same thing. So Amazon has their own like BigQuery-ish thing called Redshift or whatever. What led you to decide between one or the other? Is there anything in particular? Or?
Yeah, so actually, so the question is what made us choose BigQuery over, say, Redshift, or these days it would be like even AWS Athena, right? So there's trade-offs for these systems. I actually wrote a very long blog post for the Parsley blog, which is called Cloud SQL Engines, or no, sorry, SQL, I don't remember what it's called actually. Look for Cloud SQL Parsley on Google and you'll find it. And basically I reviewed BigQuery, Redshift, Google Cloud SQL, and RDS all as options for like fully managed SQL analytics. And there's like some description of the trade-offs there, but I'll just say basically that Athena and BigQuery are roughly equivalent choices. There's a bit more polish in the BigQuery ecosystem right now. And then Redshift is quite different. You have to really like manage your own Redshift cluster unless you use Spectrum these days, which I haven't tried yet. So, there's just kind of trade-offs in those systems, but they are roughly kind of the same use cases. Yeah.